Let's talk about the concept of density, okay? So the density is a measure of how heavy something is. And what that means is if I take a 1 kilogram, or let's talk in pounds. If I take 1 pound of cotton and 1 pound of iron, okay, and I look at those two materials, I can see 1 pound of cotton takes a lot more space, and 1 pound of iron takes very little space. So therefore, the density of iron is more than the density of cotton. So, and how do we know this? Because we're saying, hey, iron is heavier. So a measure of heaviness means that the same mass of material occupies less space, okay? So how do we quantify this? We can quantify it simply by saying that we take the mass, so we weigh it out, and we divide it by the volume. So when we take mass and divide it by the volume, what we get is the density. And we can abbreviate this as m over capital V is equal to small d, the density. Now, you can do quite a few things with this equation. If you know the mass and the volume, you can directly calculate the density. If you know the density and the mass, if you know the mass and the density, you can directly calculate the volume, okay? If you know the volume and the density, you can calculate the mass. So there's quite a few things you can do, and it's important to kind of be aware of how you can manage that. So I'll go ahead and rewrite this equation in different ways. So if you're solving for the volume, then volume is equal to mass divided by the density, okay? And if you're solving for the mass, that is going to be density times the volume, okay? So density times the volume. So depending upon what you're solving for, you want to arrange the terms certain ways so that you can solve for them correctly. Let's take a look at an example where we're trying to find the density, okay, and the sample actually weighs 0.258 grams, okay, that is the weight of the sample. And then the volume that the sample occupies is 0.215 ml, okay? So that is the mass. When we say weighs, we're really talking about mass, and that's the volume. So then the density would be equal to 0.258 grams divided by 0.215 ml, okay? And then we just simplify that, and that gives us the density. So this ends up being 1.20 grams per ml. That's the density. Now, take a look at the unit of density. That's a derived unit, okay? So you have grams over ml. Now, density can also be expressed in kilograms over liters or grams per liter, as long as the top is some measure of mass and the bottom, the volume, is some measure, which is the volume, is some measure of volume. So let's take a look at another example. Out here, we have to find the volume in cubic centimeters. So the density is given to us and the mass is given to us, okay? So to find the volume, we have to use this relationship that we pointed out, okay? So before we can use that relationship, we need to first take a look at what's happening out here before plugging and playing, okay? Since the density is given us in grams per centimeter cube, we have to change that milligrams to grams. So we have to make that change before we can insert, okay? So let's go ahead and make that change. So 22 milligrams. To change it to grams, we need to use our prefixes to understand what conversion factor to use. And if you look at the table and apply the conversion factor, you will find that it's 1 gram is 10 to the power 3 milligrams, okay? Now you can go this way, or we can do it another way. So we can do 10 to the negative 3 grams over 1 milligram, okay? So that way the milligrams cancels out, that should be an m. And then we solve for that, so that's going to be 22 times 10 to the negative 3 grams. Now we'll take this value and we'll plug it into that equation, into this equation out here. So volume is equal to mass, so that's 22 times 10 to the negative 3 grams over the density, which is 0.754 grams per centimeter cube. And if you solve for this, you should get the answer in centimeter cube because grams cancels out. So we get 0.029177 and goes on, centimeter cube. So now we have to round to the correct number of significant figures. Since the density is 3 and then the mass given to us is 2, we have to restrict our answer to 2 significant figures. So we have to stop there. So that's 0.029 centimeter cube. Now we can leave this as is, or we can change this to scientific notation. So we can move that 2 places to the right. And if you remember R and LP, if you move to the right, you got to add a negative power of 10. So that's going to be 2.9 times 10 to the negative 2 centimeter cube. There you have it.